Hello everybody, welcome into another lesson. So today we are going to talk about combinations of functions. So this also will probably seem like a review from Algebra 2, but still very important. So if you have two or more functions, you can combine them. So if you see f plus g of x, that literally equals f of x plus g of x. If you have f minus g of x, that literally will equal f of x minus g of x. If you see f times g of x, that's equal to f of x times g of x. If you see f divided by g of x, that's equal to f of x divided by g of x, provided that g of x does not equal 0, because you can't have your denominator equal to 0. So let's go ahead and do some examples. So let's see here. We have that f of x is equal to x plus 3. Then we have that g of x is equal to x minus 3. So first we're going to go ahead, we're going to find f plus g of x. So let's take f plus g of x. Well, that's going to, of course, equal f of x plus g of x, which f of x is x plus 3, so that would equal x plus 3 plus our g of x, so that'd be plus that x minus 3, which would just give you 2x. So f plus g of x would be 2x. And then we can also do f minus g of x. So to do f minus g of x, that's going to, of course, equal f of x minus g of x. So f of x is x plus 3 minus the quantity of that x minus 3, which would end up literally giving you 6. So f minus g of x is just 6. We can also do f times g of x, which of course is equal to f of x times g of x, which would end up being the quantity of x plus 3 times the quantity of x minus 3, which would just give you the difference of two squares, so you would get x squared minus 9. So f times g of x would end up being x squared minus 9. And of course we can do f divided by g of x. That's simply going to be your f of x divided by g of x, which would end up being x plus 3 over x minus 3, with one caveat, that your denominator cannot equal 0. When does the denominator equal 0? When x is 3, so that means x literally cannot equal 3. So f divided by g of x equals x plus 3 over x minus 3, where x does not equal 3. That's what you would get. Alright, let's do a couple more of these. See what we get here. F of x equals x squared, g of x equals 1 minus x. So we have f of x equals x squared, g of x equals 1 minus x. So let's go ahead, let's find f plus g of x. Again, that's just going to equal your f of x plus g of x. So that would equal x squared plus 1 minus x, and if we write this properly in descending order, it would be x squared minus x plus 1. So f plus g of x would equal x squared minus x plus 1. And now we shall do f minus g of x. Well, that's going to, of course, equal f of x minus g of x. So this would be x squared minus the quantity of 1 minus x, which would give you x squared minus 1 plus x. And if we write this in proper descending order, it would be x squared plus x minus 1. So f minus g of x would equal x squared plus x minus 1. All right, now let's do f times g of x. So f times g of x, that of course would equal f of x times g of x, which would end up giving you x squared times the quantity of 1 minus x, or simply x squared minus x to the third. So f times g of x is x squared minus x to the third. And of course, we are going to do f divided by g of x. So let's do f divided by g of x. Well, that would end up giving you, of course, f of x over g of x, which would end up being x squared divided by 1 minus x. But again, the denominator is not allowed to equal 0 because that would make the expression undefined. So when x equals 1, the denominator equals 0. So f divided by g of x is going to be x squared over 1 minus x, where x is not equal to 1. That's exactly what you would get for f divided by g of x. All right, let's see here. Alright, so we have f of x equals x squared plus 5. G of x would equal the square root of 1 minus x. So we can do f plus g of x, which would simply end up being f of x plus g of x. And then, of course, that would end up being x squared plus 5 plus that square root of 1 minus x. But we do have a domain to consider, don't we? Because we have 1 minus x, and under a radical, it has to be greater than or equal to 0. If you have any value under the radical less than 0, it's an imaginary number, which makes this undefined. So set that 1 minus x greater than or equal to 0, you would get negative x is greater than or equal to negative 1, which would have to mean that x is less than or equal to 1. So f plus g of x is going to equal x squared plus 5 plus the square root of 1 minus x, provided that x is less than or equal to 1, for where the domain is defined. That's exactly what you would end up getting. All right, so now let's do f minus g of x. That, of course, is going to be f of x minus g of x. So this would be x squared plus 5 minus the square root of 1 minus x, provided again that x is less than or equal to 1, because you don't want to have a negative value under the radical. So f minus g of x is x squared plus 5 minus the square root of 1 minus x, provided that x is less than or equal to 1. Alright, so now let's do f times g of x. And what are we going to get? We're going to get f of x times g of x. So that would end up giving you x squared plus 5 quantity times the square root of 1 minus x. Again, provided that x is less than or equal to 1, so you can make what's under the radical defined. So f times g of x is x squared plus 5 quantity times the square root of 1 minus x, provided that x is less than or equal to 1. And of course, we're going to do f divided by g of x. Whoops, wrong color. So let's do f divided by g of x. What are we going to get? Well, that would be f of x divided by g of x, which would end up giving you x squared plus 5 divided by the square root of 1 minus x. And I'm going to say don't worry about rationalizing the denominator. You can if you want, but you're going to get a really awful expression. You're best to just stick with the original way of doing it as opposed to trying to rationalize something like this. Now, here's the thing. It's true that we want to have in the denominator, because you have a radical, you don't want it to be a negative number. But it also can't equal 0 because the 0 in the denominator is undefined. So in this case, your domain is literally just x is less than 1. So f divided by g of x is x squared plus 5 over the square root of 1 minus x, provided that x is less than 1. Let's do one more of these, then we'll move on. F of x equals x all over x plus 1. G of x equals x to the third. Alright, so we have f of x equals x over x plus 1, g of x equals x to the third. So let's go ahead, let's do f plus g of x. Well, that's going to, of course, equal f of x plus g of x, which would give you x over x plus 1 plus x to the third. And you can either leave it this way or you can get the same denominator. It really makes no difference. But if we look at that first term, or regardless of what you decide to do, you notice that you have x plus 1 in the denominator. And again, your denominator can't equal 0, so x literally just cannot equal negative 1. That's the only value that would make this expression undefined. So f plus g of x is going to be x over x plus 1 plus x cubed, provided that x does not equal negative 1. All right, let's see. Let's do f minus g of x. Well, that of course is f of x minus g of x. So that would give you x over x plus 1 minus x to the third. And again, x cannot equal negative 1, because that would give you a 0 in the denominator. So f minus g of x is x over x plus 1 minus x to the third, provided that x does not equal negative 1. All right, let's do f times g of x. So f times g of x, of course, is f of x times g of x. Well, that would equal x over x plus 1 times x to the third, which would end up giving you x to the fourth over x plus 1. Again, provided that x does not equal negative 1. So f times g of x equals x to the fourth over x plus 1, provided that x does not equal negative 1. And then we'll do, let's see, f divided by g of x, which would end up being f of x divided by g of x. So this is going to be interesting. This is going to end up giving you x over x plus 1 all over x to the third. So now you have a complex fraction. This will turn into x over x plus 1 times 1 over x to the third, which would end up simplifying into 1 over x squared times x plus 1. But we just changed our denominator. So f divided by g of x is 1 over x squared times x plus 1, but there's actually two values for which can make the denominator undefined. You set x squared equal to 0, you'll get 0. So x definitely cannot equal 0, and it also can't equal negative 1 because of that x plus 1. So f divided by g of x is going to equal 1 over x squared times x plus 1, provided that x does not equal 0 or negative 1. All right, let's shift gears a little bit. Let's see, f of x equals x squared minus 1. G of x equals x minus 2. So here's where it's going to change a little bit. We're going to find f plus g of 3. So how do we do that for a number? How do we find f plus g of 3? Well, that's no different than f of 3 plus g of 3. Alright, so what is f of 3? I'm going to make some brackets here to denote each function. So f of 3, you put in the 3 for that x squared, so that's going to be 3 squared minus 1, that quantity, plus for the g of 3, that would be 3 minus 2. So you would end up getting 9 minus 1 plus 1, which would just give you 9. So f plus g of 3 is going to be 9. right, let's find f minus g of negative 2. So we're going to find f minus g of negative 2. Well, that's going to be the same thing as f of negative 2 minus g of negative 2. Which, let's put up some brackets again. If I put a negative 2 for my f, that would end up giving me negative 2 to the second power minus 1. That quantity minus, if I put a negative 2 for g, that would give me negative 2 minus 2. So this would turn into 4 minus 1 minus negative 4, which would be the same as 3 plus 4, which would be 7. So f minus g of negative 2 ends up being 7 when I work that out. Let's use a different color. Now, what if I did fg of 4? I'm going to do fg of 4. Well, that's going to be the same as f of 4 times g of 4. So f of 4, that's going to be 4 squared minus 1, that quantity, times that g of 4, so that would be 4 minus 2. So let's see, the first set of brackets, you would get 16 minus 1 times 2. Well, that would just give you 15 times 2, which would be 30. So f of g of 4 would end up being 30 by the time you work that out. Alright, let's see. We have f divided by g of 0. So we have f divided by g of 0, so that's going to be the same as f of 0 divided by g of 0, which would end up giving you 0 squared minus 1 over 0 minus 2, which would give you negative 1 over negative 2, which would give you a value of positive 1/2. So f over g of 0 is equal to positive 1/2. So we've substituted in numbers. We found combinations of functions for numbers. You can also do it with algebraic expressions. So for example, let's do f minus g of 2t. So I'm going to do f minus g of 2t. Well, this is going to be the same as f of 2t minus g of 2t. Now for each function, I'm going to set up brackets and put in 2t for my x values. So that would give me 2t to the second power minus 1 for the f of 2t, minus another bracket. If I put in 2t for x, that would give me 2t minus 2. So let's see, in the first bracket, I would have that 2t squared is 4t squared minus 1. This would be minus 2t plus 2. So this is all going to simplify into 4t squared minus 2t plus 1. So f minus g of 2t ends up being 4t squared minus 2t plus 1. Alright, let's do f plus g of t minus 4. So we're going to take f plus g of t minus 4. Well, that's going to be the same thing of as f of t minus 4 plus g of t minus 4. So now set yourself up some brackets. So if we put in t minus 4 for that x and f of x, that would give you the quantity of t minus 4 to the second power, then minus 1. Plus, if you do it for g, put in that t minus 4 for x, that would give you t minus 4 minus 2. So your first bracket, you do the binomial expansion to the second power. That's going to give you t squared minus 8t plus 16 minus 1. All that plus t minus 6, which would make this simplify into t squared minus 7t plus 9. So f plus g of t minus 4 is going to be t squared minus 7t plus 9. All right, we're going to take f times g of 3t squared. So we're going to take f times g of 3t squared. So that'll be the same as f of 3t squared times g of 3t squared. So let's do the first set of brackets. That would end up, if you put 3t squared in for x there, you would end up getting the quantity of 3t squared to the second power minus 1 times your, if you put in 3t squared in your g of x, that would give you 3t squared minus 2. So let's simplify the first bracket. That would end up giving you 9t to the fourth minus 1 times the quantity of 3t squared minus 2. And now you just have a simple foiling. This would be 27t to the sixth minus 18t to the fourth minus 3t squared plus 2. So f times g of 3t squared gives you 27t to the sixth minus 18t to the fourth minus 3t squared plus 2. And you knew it, a division 1 was coming. A division 1 is definitely coming. Let's do f over g of t plus 2. So we're going to do f divided by g of t plus 2. Well, that's going to be the same as f of t plus 2 all over g of t plus 2. So for f, you'll put in that t plus 2 for that x, so you'll have t plus 2, that quantity squared, minus 1 over your g of t plus 2, so that would be t plus 2 minus 2, which would end up in the numerator giving you t squared plus 4t plus 4 minus 1 all over t, which would simplify into t squared plus 4t plus 3 all over t, but there's just one problem. We have a denominator of t, which means t can't equal 0. So f divided by g of t plus 2 is equal to t squared plus 4t plus 3 divided by t, where t does not equal 0. Alright, so I think you've seen enough combinations. Now let's go on to compositions. That also may ring a bell from Algebra 2. So let's talk about compositions. Which compositions are going to come into play in the next lesson when we talk about inverse functions. But let's say you have f composition g of x. It looks like fog with that dot in the middle, but f composition g of x, this literally means f of g of x. So you're putting a whole function into the other function. Or you could also do g composition of f of x, which would end up being g of f of x, and they're not necessarily going to be equal to each other. These two do not always equal each other. So you have to know what you're substituting in. This is just two of many ways you may see it. So that's what a composition is. Now let's go ahead and get started here on some examples. All right. We have f of x equals the square root of x plus 4. Then we have g of x is equal to x squared. So up first, we're going to seek to find f of g of x. Let's find f of g of x. So that means it's going to be f of g of x. So in other words, g of x was x squared. This would end up being f of x squared. So now for f of x, you just put in that x squared for x. You would end up getting the square root of x squared plus 4. And let's look at the domain of f of g of x. You have x squared plus 4 under the radical. Are there any values that's going to give you a negative number? Not at all. X squared plus 4 is the sum of two squares, so the domain in this case is all real numbers. So everything works for your domain for that. Now let's say we switch it around a little bit. Let's say we take g of f of x. So we're going to take g of f of x. So that would be, or g composition of f of x. So that would be g of f of x. Well, what is f of x? That's the square root of x plus 4. So that would be g of the square root of x plus 4. Which means now you'll just put in that x plus 4 in the x squared. So that would give you the square root of x plus 4 raised to the second power, which will cancel out the square root. You'll just get x plus 4. And the domain is going to, of course, be all real numbers. Since it's a polynomial, your domain is automatically all real numbers. So you get x plus 4 with your domain being all real numbers. Alright, let's see. F of x equals the cube root of x minus 1. G of x equals x cubed minus 1. So we have f of x equals the cube root of x minus 1. G of x equals x cubed minus 1. So first let's find f composition g of x, which is going to be the same thing as f of g of x. Well, g of x is x cubed minus 1, so that would end up giving you f of x cubed minus 1, which now you'll put in the x cubed minus 1 for the x. That would end up giving you the cube root of x cubed minus 1. Then you have that minus 1 under the radical. So this would turn into the cube root of x cubed minus 2. And now let's look at the domain. It's a cube root, so you don't have to worry about imaginary values. Your domain for this one's going to be the set of all real numbers. So f composition g of x is the cube root of x cubed minus 2. And then you'll have the domain is going to be the set of all real numbers. Then we can work backwards, of course. Let's do g composition of f of x. So that means you're taking g of f of x, which would give you g of the cube root of x minus 1. So put in that cube root of x minus 1 for x cubed. So let's see here. That would be the cube root of x minus 1 raised to the third power minus 1. Well, the cube root raised to the third is going to cancel out that cube root. You'll just get x minus 1, which would give you x minus 2. So g of f of x just equals x minus 2, and since it's a polynomial, your domain is automatically the set of all real numbers. So g of f of x equals x minus 2, the domain being the set of all real numbers. I got 4 more. F of x equals 1/3 x minus 3. G of x equals 3x plus 9. So f of x equals 1/3 x minus 3. G of x equals 3x plus 9. Okay. Let's go ahead and find f composition g of x, which would of course equal f of g of x, which would give you f of 3x plus 9. Now in f, put in that 3x plus 9 where you see x, so you would get 1/3 times 3x plus 9, all that minus 3, which would end up giving you x plus 3 minus 3, or simply x. And of course, your domain would be all real numbers. Now this is interesting. Since f composition g of x equal just plain old x by itself, in the next lesson we're actually going to see that that would mean that g of x and f of x are inverse functions of each other. So I guarantee you, when we go to do g of f of x, we should get x again. And I'm going to prove that, which would mean these two are inverse functions of each other. But we'll delve more into that in the next lesson. So g of f of x, or g composition f of x, that equals g of f of x, which would give you g of 1/3 x minus 3. That's a bad g. Alright, which would end up equaling 3 times 1/3 x minus 3 plus 9. So that would end up giving you x minus 9 plus 9, or just simply x. And your domain is going to still be the set of all real numbers. So both ways we have proven that these two are inverse functions of each other. And with inverse functions, if they're truly inverses, it doesn't matter if you take f composition f inverse of x or f inverse composition of f of x. You should get x both times, which would prove they're an inverse. But that's just an interesting side tidbit to prepare you for the next lesson. Alright, I got 3 more. Oh, good one. F of x equals the square root of x, so does g of x. F of x equals the square root of x, g of x equals the square root of x. So let's find f composition g of x. F composition g of x, well, that of course would equal f of g of x, which would end up giving you f of the square root of x, which would mean you're going to have the square root of the square root of x, which is going to simplify into the fourth root of x, because the square root of the square root is the fourth root. So f composition g of x is the fourth root of x. Now, much like a square root, even number roots are only defined for 0 or positive values. So this is provided, or I should say your domain is such that x is greater than or equal to 0, or the domain is from 0 inclusive to infinity, however you'd like to say it. And if we put in g composition f of x, guess what? Since they're both the same function, you're going to end up with the fourth root of x with the exact same domain. So there's really no point in sitting here doing g composition of f. You'll actually get the same thing in this case. One of the rare times that they're identical and equal, but two more. F of x equals x to the 2/3. G of x equals x to the 6th. Alright, so f of x equals x to the 2/3, g of x equals x to the 6th. So let's go for f composition g of x. That would end up, of course, giving you f of g of x, which would be f of x to the 6th. So if I put in x to the 6th for that x to the 2/3, so x to the 6th raised to the 2/3 power, that would end up giving me x to the 4th. And since it's a polynomial, or more specifically a monomial, the domain's going to be the set of all real numbers. So f composition g of x is x to the 4th. The domain's a set of all real numbers. And of course, let's do g composition f of x. So that would be the same as g of f of x, which would be g of x to the 2/3. So now put in that x to the 2/3 for x to the 6th. This would be the quantity of x to the 2/3 raised to the 6th power, which would end up being, once again, x to the 4th, with your domain being the set of all real numbers. I got just one more. F of x equals the absolute value of x. G of x equals negative x squared plus 1. Alright, so let's find f composition g of x. Well, that's going to be the same as f of g of x, which would end up being f of negative x squared plus 1. So now you'll just put that into your absolute value function. You would get the absolute value of negative x squared plus 1. And since it's an absolute value function, there's nothing that would make your domain undefined. So your domain is going to be the set of all real numbers. So f composition g of x is negative x squared plus 1, the absolute value of that quantity. Your domain is going to be the set of all real numbers. Now let's do g composition f of x. Well, this is going to be the same as g of f of x, which would be the same as g of the absolute value of x. So this is going to be the same as negative of the absolute value of x squared plus 1. Well, okay, whatever your absolute value is, the absolute value at the least will be 0, right? But if it's a negative number, it becomes positive. And if you square it, that's a double positive. So really all this is going to turn into is negative x squared plus 1. You're going to literally end up getting g of x back. You'll end up getting negative x squared plus 1, where the domain is going to be the entire set of real numbers. So g of f of x equals negative x squared plus 1, where your domain is the set of all real numbers. So that's it for the combinations of functions lesson. Next lesson we are going to talk about inverse functions. So I hope everyone has a great day. Take care.